Have you ever wondered what it's like on other planets? What sights would await you on the red dunes of Mars? What it would be like to dance on Saturn? What's waiting beneath the swirling clouds of Jupiter? Yeah, lots of things would kill you before you ever found out. The heat or the cold, radiation, potentially crushing gravitation, and either a total lack of atmosphere or a miasma of poison gases. But we're learning more and more about the conditions on our celestial neighbors all the time, so it's not hard to imagine what it would be like to pay them a visit. Take Mercury, for example, the Sun's closest pal. Because it's only 58 million kilometers from the Sun, compared to Earth's 150 million kilometers, on Mercury the Sun would appear 3 times larger than it does from Earth, and 6 times brighter. So, wear sunscreen. And because it's the closest, Mercury has the shortest orbital period in the solar system, completing 1 circuit around the Sun in just 88 Earth days. But as it travels around the Sun, Mercury actually rotates relatively slowly. 1 full rotation, which would be 1 day on Mercury, takes about 58 Earth days. So the planet ends up experiencing roughly 3 days for every 2 of its years. It's also a cute little thing as planets go, about 4,900 kilometers in diameter. That's about 40% larger than our moon, but it's still only as big across as the continental United States. And as you headed towards the planet, you'd see that it looks a lot like our moon, gray, rocky, and uneven. Unlike the moon though, its surface is rippled with towering ridges called lobate scarps, which were created when Mercury rapidly cooled after it formed more than 4 billion years ago. In the process of cooling, the planet actually shrank by as much as 11 kilometers in diameter, giving it an appearance that's been compared to a dried apple. As you get even closer to Mercury, you'd pass through its exosphere, a thin layer of oxygen, hydrogen, helium, sodium, potassium, and other materials, most of which have been knocked off the planet's surface by solar wind and meteoroids. And because it has no significant atmosphere to burn up any rocks flying at it from space, Mercury is also heavily cratered. One impact 4 billion years ago was so nasty, it created a crater roughly 1,550 kilometers wide, known as the Caloris Basin. It's basically the size of Texas. Now, you might well think that Mercury is the hottest planet in the solar system because it's the closest to the Sun. But you'd be wrong. That distinction actually goes to Venus. Since Mercury has such a meager atmosphere, it's not very good at retaining heat, so it can get a lot colder than you might think. Daytime temperatures can reach 430 degrees Celsius, sure, but at night they drop to negative 180 degrees. That's the biggest temperature swing in our solar system. And in fact, if you were to land in the right crater on Mercury, you might even find ice. Astronomers think they've found evidence of water ice lurking at the North and South poles, where there are craters so deep that they're perpetually shadowed and cold. This water was probably delivered to Mercury by the same impacts that gave the planet its pockmarked complexion. So, one last weird thing to keep in mind if you're planning a trip to Mercury is that you'd feel a lot lighter there, but not as light as you might expect. Even though Mercury is only 40% bigger than the moon, it actually has about twice the gravitation. Standing on Mercury, you'd experience 38% the force of gravity that you'd experience on Earth, compared to just 16% on the moon. What gives? Despite its small size, Mercury is actually the 2nd densest planet in our solar system, thanks to its huge metallic core. At roughly 3,700 kilometers wide, its liquid iron core takes up about 75% of the planet's total diameter. Since it's so packed with mass, Mercury exerts stronger gravitation, resulting in a lighter step than you'd take on Earth, but not quite the bounce that you'd get on the moon.
Mercury, in Roman mythology, is the god of merchants and travelers, transporters of goods and thieves. Given what we've got planned for Mercury's future, that planet is well named indeed. So today we are returning to the Outward Bound series after a few months hiatus to look at colonizing Mercury, probably one of the most neglected planets in science fiction. Mars gets a lot of attention, as does Venus, but even the various moons get more attention than Mercury does. This is a pity, because there are a lot of options there for Mercury, some of which we've mentioned in passing before, And when I sat down with the production crew on our SFIA Discord server to chat about those, we came up with pages of different possible approaches to making Mercury useful, and even a pleasant place to live. Traditionally, Mercury is seen as having one big problem and one big use. It's scorching hot because it's so close to the sun, and being basically a big airless ball of silicon and metal, we usually figure on using it as a giant building supply store to construct power collectors, and in the long term to completely disassemble it to form the basis of a Dyson swarm. But there's a lot of time between starting up some mines and power collection near Mercury and totally disassembling it. Taking apart planets is not a fast process, and requires civilizations to exist far longer than any in our history. We often talk about the problems in science fiction, and futurism in general, of people not really getting scale right, and Lifetimes of Colonies is a good example of that. We might point at a supergiant star with a lifetime of 100 million years, already more than halfway done, and say, you wouldn't colonize that, while forgetting that compared to any civilizations which have ever existed, that's nearly an eternity. If some big island rose up from the depths of the Pacific tomorrow, covered in fertile mud, and geologists said it would sink in 1,000 years, many would of course rush to claim and colonize it. Many folks would shake their heads and point out that it was doomed, but the last laugh would presumably be on them, since that's a millennium for a culture to flourish on. Even Rome, the eternal city, and the standard by which we tend to judge long-lasting civilizations, lasted only about this long. You don't need to be around long to have a lasting impact on humanity, our culture or technology, let alone just have a long and productive life. Nor is the need to eventually move really a problem. After all, your ancestors would have moved or you wouldn't be there. So not only can a great civilization be worth having even if it would only last a few centuries, but it's quite rare for them to even last that long. That's something worth remembering when we talk about colonizing places. They'd go through a lot of phases and a lot of history, even if they had much sooner expiration dates than billions of years. Whether or not Mercury might get disassembled is probably a long way down the road, so today we'll focus on near and mid-term colonization. But let's start by talking about Mercury and how and why we want to start a basic colony there. Mercury, of course, is the closest planet to the Sun, and thus we tend to think of it as the hottest, but Venus beats it out slightly for peak temperature, and Mercury gets downright cold at night. Unlike Venus, it has no atmosphere worthy of note, just a thin haze of mostly hydrogen and helium from captured solar wind that soon enough evaporates away and gets replaced by more of it. The surface pressure of that atmosphere is less than in low Earth orbit by the space station, and so can be mostly disregarded. Like Venus, it has a peculiarly long day. It was once believed to be tidally locked to the Sun, like the Moon is to the Earth, which means a 1-to-1 orbital resonance where the day and year are the same length, leaving one side eternally lit by the Sun and the other in darkness. But actually, Mercury is in a 3-2 orbital resonance, meaning it rotates on its axis 3 times for every 2 orbits around the Sun, which it does every 88 days. It rotates once on its axis every 59 days, 2/3 of 88 days, but that is not its day-night length. Indeed, Earth doesn't take 24 hours to rotate 360 degrees, just 23 hours and 56 minutes, what we call the sidereal day, the time for one complete rotation. But as it's moving around the Sun, it takes just a bit longer on each rotation for the Sun to be in the same place, to set on the horizon. Just 4 minutes, resulting in a 24-hour day-night cycle, what we call the synodic day, though of course we just call it the day. However, on Mercury the rotation is so long, and the orbit so short, that this effect is considerably magnified. The sidereal day on Mercury is 59 days long, while the synodic day, the time for one day-night cycle, is 176 days, or 2 Mercury years. That's a very long time to wait between sunrises and sunsets. More importantly though, with an equatorial circumference of just over 15,000 kilometers, the day-night terminator only moves 87 kilometers a day, or 3.6 kilometers per hour at the equator, walking speed. Move up north or south to say 60 degrees latitude, and that's cut in half. At 76 degrees, it would be only a quarter, and you could keep ahead of the rising sun if you were strolling and camping to rest along the way. We'll be talking about mobile bases, colonies just rolling around on wheels or rail later today, and they wouldn't need to move too fast, particularly up by those poles. If you're curious, if you take the cosine of your latitude, north or south, and multiply it by the planet's circumference, 15,300 kilometers for Mercury, or by pi times its diameter, then divide by how many hours in its day, that will tell you how fast you need to move to keep up with the sun, such that it would never set or stay out of it, so it would never rise. Ideally, you don't want to be around when the sun is up on Mercury, since the temperatures at noon would flash fry you. But you wouldn't want to be there at midnight either. Its temperature ranges from hotter than your oven to colder than liquid oxygen or nitrogen. So if you could be mobile, you'd probably want to chase around that terminator, staying just where you could catch some solar power, but where it hadn't heated up or cooled down much yet. You'd presumably have a ring rolling around the planet's poles that was a comfortable room temperature, and want to stay near there if you could. As I said, Mercury is not tidally locked. It doesn't have a stationary day and night side. There's some debate if this might ever change, as Mercury has a particularly high orbital eccentricity, which makes a 1-to-1 resonance less likely. Indeed, it's the most eccentric orbit of any planet, now that we don't count Pluto, which is so eccentric that it is often closer to the Sun than Neptune, and in fact was from 1979 to 1999. Mercury doesn't ever become our second planet, even at aphelion. When it's furthest from the Sun at 70 million kilometers, it's still a lot closer than Venus ever gets, but at perihelion, Mercury gets to just 46 million kilometers from the Sun. That means it gets half again as far from the Sun at aphelion than perihelion, and since light from the Sun falls off inverse square of the distance, it only gets 40% as much light and energy at aphelion as it does at perihelion. So even keeping up with the terminator won't give you a stable temperature. Nor is that sunlight very healthy, even where the temperature hasn't risen much yet. There's no air there filtering out the harmful frequencies of sunlight. This, of course, is one approach to colonizing Mercury for mining. You set up your camp where it's cool and move on when the light and heat are too much. You drive ahead to someplace that's colder, but not quite so cold you can't walk there. Set up your camp again and do some more mining and move on. Think of the sand crawlers from Dune that harvested the spice melange, only you're running from the sun rather than giant sandworms. You probably want to make sure you've got backup vehicles and engines in case one dies, and you can use the extra energy while moving to power your smelters and refineries. Needless to say, heating things up on Mercury to smelt them isn't too hard. A solar oven would work quite well there, with no clouds and being that close to the sun. Mercury's night side is also a good place to get rid of heat, something hard to find anywhere else near the sun. You can create a cool day anywhere in space by just putting a mirror between you and the sun, but if you're generating a lot of heat, you can only get rid of that by radiating it away. Down on Mercury's night side, you can use conduction too, so you might have mobile factories at work, not just mining and refining operations. Of course, getting what you produced off Mercury isn't too hard either. Mercury has an escape velocity of just 4.2 kilometers per second, and an orbital velocity of just 3 kilometers per second. Moreover, it has no air, so you don't even need any of those impressive launch systems we discussed, like launch loops or orbital rings. If you had a flat track you could drive on down there, without worrying about friction on the wheels, you could literally drive down that highway, flooring your engine, until your car left the ground. Not because you'd hit flight speed, there's no airlift or drag, but because you'd hit orbital speed. Setting up a track something can run down, a mass driver, is a lot easier here because you don't need a tube around it to evacuate air out. You have way weaker gravity, so building tall is easier, and you need less speed. And you don't have to elevate the launch tube anyway, as there's no air to lift it over, so you just have to bridge over any craters you came across. It's actually landing on Mercury that's a pain, as again there's no air, so much like on our moon, we can't aerobrake to shed velocity for free. Though you might be able to hit a very long track, very precisely, and slowly shed speed off without friction, or run down a magnetic tube, the reverse of a typical mass driver, to let it leach your speed off as power, rather than inserting power to give a ship speed. This gives you a good reason to consider building a track all the way around Mercury, and it need not be at the equator either if you wanted to keep it shorter. Mercury gets hot, but it is still cool enough for many metals to handle. Even steel, which is fairly mundane considering some of the materials we might use, retains its magnetic and conductive properties at those temperatures, and one thing Mercury is not lacking in is metals. One would still have to worry about metal fatigue though, as some metals there would be expanding and contracting to varying degrees as they ran up from temperatures cold enough to liquefy air to temperatures hot enough to melt lead. But this is happening once a Mercury day, which is very long.